Hi everyone, this is Jessie and Esendan Berhad, and we are back with our project titled The FarmWise 2.0. So, the assigned problem given to our group is the soil erosion in a gently sloping sandy loam field situation, where a slightly sloped area with a sandy loam soil located near a river are prone to erosion during a heavy rain, and the overflow and also the surface runoff wash away the topsoil and also seedling of maize, cassava, and soybean. This will lead to the nutrient loss and also poor crop establishment. So how this problem affect our farm and crop is, the first one, it causes a significant nutrient loss from the topsoil, degrading the long-term fertility and also productivity of the field. And the second one, the poor crop establishment will reduce the crop yield due to the physical loss of seedling of the cassava, soybean, and also corn. The third one, it will decrease the water infiltration, meaning that valuable rainwater is lost as a runoff rather than being stored in the soil for the crop use. For problem background, the first problem is the unsuitable planting orientation, where in our previous design we used a rectangular parallel arrangement of the plantation block, which likely oriented up and down the gentle slope towards the river. And the effect of this is when a heavy rain, this will create a channel for water, increasing the runoff velocity and soil loss, which will strip away the topsoil and seedling. This also will affect the nutrient and resource wastage, where the valuable topsoil and also applied nutrient are immediately lost as a runoff into the river. This represents a waste of resource and negates the effort of creating closed-loop nutrient cycle. So the second issue for our farm is the absence of the soil conservation structure, where in our previous design there are no contour ridge, grass strip, and also terrace between our plantation block. So the effect is, without this barrier, there are nothing to slow down the water flow during heavy rain and to trap the eroded soil or promoting the water infiltration, which leaving the sandy loam soil vulnerable. Therefore, in this project, we will improve our design by designing an effective soil conservation layout by incorporating the contour ridge, vegetative barrier, terrace, and also grass strip. This will sustainably reduce the soil erosion and also increase the water infiltration in the gently sloping sandy loam field. Thereby, it will help to protect topsoil, conserve nutrient, and ensure a successfully establishment growth of maize, cassava, and soybean crop.
I will be presenting our new proposed design. If you can see here, this is our old design, this is our water system, this is our old plantation area, this is supposed to be our old poultry area, this is supposed to be our old aquaculture area, and this is supposed to be our old compost area, and this is our old electricity area. This is our new redesigned farm. This is supposed to be our water area, this is supposed to be our aquaculture area, compost area, electricity area, poultry area. This is our redesigned farm area. This is our new redesign, which is we designed it in the terrace contour area, contour plantation, which is this is our first plan, that is our second plan, and that is our third plan. And in between them is napier grass, which will act as a cover crop to reduce the soil erosion by allowing the napier grass root to grab on the soil to reduce soil erosion. And at the bottom of the plantation area is a sedimentation pond, which will capture any runoff before it go into a river. And also this is our post harvest station, and also the area is built of slope design, which if any runoff like right now it is raining, the rain will fall to the sedimentation pond.
As Akmal already explained in the previous video, contour ridge function is to reduce soil erosion by acting as a small barrier that slows the downhill flow of water and trap sediment, while improving water infiltration by holding water in place, allowing it to seep into the soil, then running off. The second function of grass strip is napier grass. It can reduce soil erosion by slowing the speed of runoff, decrease its power to carry soil, and allow soil and sediment to settle out of the water before it moves further downhill. The third one, the buffer zone. Buffer zone controls soil erosion by vegetated plants that slow water flow, trap sediments, and increase water infiltration into the soil. The last one is lake, as in water reservoir. Water reservoirs such as dams and check dams reduce soil erosion by slowing down and controlling the flow of water, which minimize its destructive force and topsoil washing. So, how contourage can reduce soil erosion? It can maintain soil integrity, trap sediments, slow water flow, and anchor soil. However, it can also reduce water infiltration by increasing contact time, allow seepage, and enhance water retention and conserve water. By using grass strips or Napier grass, how does it reduce soil erosion? It can slow down runoff, reduce coring force, trapping sediments, and intercept runoff. And how does Napier grass can reduce water infiltration? It can increase surface roughness, providing pores for infiltration and reducing runoff volume.
This shows that before the prototype, the soil direct run off through the slope of the soil. With the help of cover crop, contouring, and the buffer zone, the soil erosion being decreased and the water is being filtered before it wash direct into the lake. This is the overall water flow after we improve through this prototype.
So for the expected outcome for the contouring and reach, how does it impact on the crop health and growth? So firstly, it will prevent the washing away of topsoil and young seedling, and also it even does water distribution, which also will increase the soil moisture. Next, the impact on the resource efficiency. It conserves soil nutrient by preventing loss through runoff and also reduce the need for repeated fertilizer application. So for the second one, we have the cover crop here. We're using the cover crop to reduce the soil erosion. So firstly, the impact on the crop health and growth. It protects bare soil from direct rain impact and also minimizing crusting and also erosion. The root stabilize the sandy loam soil and also add organic matter, improving soil structure and also the fertility. Which the impact on the resource efficiency is to improve soil water retention while reducing irrigation frequency. So it will reduce the use of water and reduce the cost, and also it will also enhance long-term soil productivity through organic matter build-up through nitrogen fixation. Next, in our farm, we are also using buffer zone, which impact on crop health and growth. It protect the plantation area from flooding and riverbank erosion. We'll also maintaining the stable growing condition of the plant in the farm. It also provide habitat for pollinators and beneficial insects, supporting healthy crop ecosystem. And how does it impact the resource efficiency is to prevent nutrient and pesticide runoff into the river. It also keeping input within the field. Next, it also acts as a natural filter, improving downstream water quality and also promoting ecosystem balance. Lastly, in our farm, we also integrate a lake for a water reservoir in our farm. So the impact on the crop health and growth is the lake at the field lower and capture and store runoff water, which can be reused for irrigation during dry periods. So the runoff will not directly into the river. And also it stabilizes water availability, preventing drought stress and promoting consistent crop growth. So how does it impact the resource efficiency? It enables water recycling and reduce dependency on external water sources. It also lastly control nutrient loss and sediment flow, maintaining the field fertility.
In conclusion, the proposed soil conservation layout centered on the combinations of contour farming, specifically contour ridges, and vegetative barriers using grass strips provides a robust, practical, and sustainable solutions to mitigate soil erosions, and enhance water infiltrations in the gently sloping sandy lawn fields. This proposal can achieve 4 key points, which are erosions control, efficient water management, better nutrient retentions, and promote sustainability. In essence, this integrated approach transforms the field from a system that facilitates runoff and erosions into one that actively captures water and soil, leading to a healthier, more productive, and ecologically stable agriculture environment. Regions for rain, grass for gain, keep soil where it should remain. That's all from us. Thank you.